Okay, today we're going to look into how do we find the nth term of a geometric sequence. Okay, so yesterday we did arithmetic, today we do geometric, and we'll talk about the differences. A geometric sequence is whenever the ratio between any term and the previous term is constant. Yesterday it was just a common difference, right? So that common ratio is r. So if we look at this, is the sequence geometric? We just look at the ratio between any two consecutive terms. So the ratio between -4 and 1, -4 over 1 equals -4. Now if that ratio stays constant, then it's geometric. What's 16 over -4? -4. What's -64 divided by 16? -4. Okay, so we can assume that this is geometric now. 256 divided by -64 is also -4. So what does r equal? -4. Rules for a geometric sequence. A sub n equals a sub k times r to the n minus k. That's if a is not, or the k is not equal to 1, or the one that you see most often on the internet is like a sub n equals a sub 1 times r to the n minus 1. So we're going to use this to write the first three terms of the sequence. We're given a sub 1 equals 2 and r equals 2. So really it doesn't matter what formula we use. I mean, we were given a sub 1, so we can use this formula over here. Okay, so to write the first three terms of the sequence, first we have to figure out like a formula for that sequence. So I say a sub n equals a sub 1. What is a sub 1 equal to here? 2. And the r? 2 to the n minus 1. Alright, I'm writing the first three terms of the sequence. I already know the first term. Now I need to figure out the second. So a sub 2 would be 2 times 2 to the 2 minus 1. Well, what's 2 minus 1? 1. So that's just 2 times 2 to the first, which is equal to 4. Yeah, that's right. Alright. The third term in the sequence, 2 times 2 to the 3 minus 1. 3 minus 1 is 2. So we have 2 times 2 squared. What's 2 squared? 4. And then times 2? 8. Okay, let's look into how we would find the nth term of this sequence and then find a sub 6 given the sequence 2, 6, 18, 30, 54. Okay, so the first thing I'm going to do is I'm going to label the terms of my sequence. This 2 is my a sub 1, a sub 2, a sub 3, 4, so on. Okay, my first step is that I need to figure out what the common ratio is between these terms. So r equals, how would I find r? Yeah, just any of the term divided by its previous term. So 6 divided by 2 is 3. Check ourselves just to make sure. What's 18 divided by 6? 3. Okay, so now we remember that a sub n is equal to a sub k times r to the n minus k. But the easiest k to use would be 1. So we're going to use this term right here. A sub n equals, what would a sub k be in this case? 2 times r, which was 3, to the n minus 1. Okay, so I found the rule for the nth term. That's the rule. How would I find a sub 6? Plug in the 6. So a sub 6 equals 2 times 3 to the 6 minus 1. Well, that's just 2 times 3 to the 5th. So that's 2 times 2, 43. So a to the 6th, or a sub 6 is 486.
Looks like this, though, wouldn't it just be?
Okay, given that a sub 3 equals negative 18 and r equals 3, we're going to write a rule for the nth term of this sequence. What's the general rule again? A sub n equals a sub k r to the n minus k. Well, I have enough things. A sub n would be, what's a sub k in this case?
Negative 18.
Negative 18 times 3 to the n minus 3. Okay, lastly, we're going to write a rule for the nth term of the sequence given only 2 terms in the sequence in their place. So yesterday with arithmetic, we had to do like a whole slope situation and all that kind of stuff. We're not going to do that today. So first thing, let's just remember the general form again, because a sub n equals a sub k times r to the n minus k. All right, so the way that I found to do this the easiest is just to treat one of these as like your k's and one of these like the n's. Okay, so if I'm using this a sub 7 equals negative 320 for my n's, what would a sub n equal? Negative 320, that's right. And what would a sub k equal? To fill in this formula over here. 10. Now, I was not given r to the n minus k. So what's n? 7. Yeah, a sub n was our negative 320, so n would be the 7. And what would k be? 2. All right, so now that's negative 320 equals 10 times r to the 5th power.
Does it matter which one's k and which one's n?
All right, order of operations tells me I have to divide both sides by 10 first. So now negative 32 equals r to the 5th. To get rid of that to the 5th, I have to take the 5th root of both sides. So this would be to the 1/5. And the 5th root of negative 32 is negative 2. All right, yesterday, once we solved for d, we just chose one of the terms of the sequence. We're going to do the exact same thing here. Now that I have r, I'm going to just choose one of my terms. I'll choose this one. And I'm going to plug it back into the general form. So a sub n equals a sub k, 10 times negative 2 to the n minus 2. So this formula will give you any term in the sequence. We could use this to solve for a sub 1 and then write the formula in the terms of like n minus 1. Just like the thing that we saw earlier. But let's use this to solve for the first term in the sequence. A sub 1 equals 10 times negative 2 to the 1 minus 2. Okay, so a sub 1 equals 10 times negative 2 to the negative first power. Negative powers send things into the denominator, so 10 times 1 over negative 2. What's the first term in the sequence? 10 times negative 1/2? negative 5. So I'll take this answer above the 10 times negative 2 to the n minus 2, but I could write it as a sub n equals negative 5 times negative 2 to the n minus 1. And those are geometric sequences.